Hello everyone, welcome back. Avneet here from Planet Spark. Today we are unlocking the superpower of mathematics. Exponents and powers, a tiny number written at the top, but it can create huge values. Let's discover how this magic works. Exponents and powers. We learn to identify the base and the exponent in the exponential expression. Exponents represent repeated multiplication. We'll learn how to expand the exponential expressions. We'll recognize the real life use in computer science and daily life and learn to simplify and solve. What basically are exponents? Exponent, it is a small number written at the top of the right to the another number. The number at the bottom is called the base and on the top is called the exponent. I can read it as 2 raised to the power 3. So 2 is the base, 3 is the power or which I call exponent. Again repeating 2 raised to the power 3 is it is read as 2 is the base, 3 is the exponent. Next is 5 raised to the power 7, 5 is the base, 7 is the exponent. So remember the number which is written at bottom is the base and which is written right above is the exponent. But why do we need exponents? Imagine writing 2 into 2 into 2 into 2 into 2 so many times. Instead of writing it repeated as repeated multiplication again and again, we just simply use exponents. So repeated multiplication gives us exponential form. Let's take an example. If I write down 5 raised to the power 3, 5 is the base, 3 is the power. This means that the base would be multiplied 3 times. So 5 would be multiplied 3 times. 3 raised to the power 4. 3 is the base, 4 is the power. So base 3 would be multiplied 4 times. Next example, 10 raised to the power 2. 10 is the base, 2 is the power. 10 would be multiplied 2 times. 7 raised to the power 3, again 7 is the base, 3 is the power, so we'll multiply 7 3 times. Some special cases arise over here related to power 1 and power 0. What happens if my power is 0? Any number raised to the power 0 is 1. 7 raised to the power 0 is 1. 100 raised to the power 0 would be 1. So any number raised to the power 0 is going to give us 1. Minus 50 raised to the power 0 would again be 1. The next case that arises is if I'm having a number which is raised to the power 1. Any number raised to the power 1 is the same number. So a raised to the power 1 will be a. 5 raised to the power 1, that means 5 is multiplied only one time, so it is 5. 37 raised to the power 1 is 37. 63 raised to the power 1 means 63 is multiplied just once, so answer is 63. Minus 5 raised to the power 1 is again minus 5. Let's simplify a few questions. Let's learn how to evaluate. First part, we'll evaluate 3 upon 4 whole square. So 3 upon 4 whole square means 3 is 3 raised to the power 2 as well as 4 raised to the power 2. Now 3 raised to the power 2 is 3 into 2 into 3 divided by 4 into 4. 3 into 3 is 9, 4 into 4 is 16. Dig in with the next example. The next example is 4 raised to the power 3. 4 raised to the power 3 means 4 is multiplied 3 times, so it is 4 into 4 into 4. 4 4s are 16 and 16 4s are gives me 64. Let's take another example. If I have minus 2 over 3 whole raised to the power 3. Now this will mean that minus 2 is multiplied 3 times. So it is minus 2 into minus 2 into minus 2. Upon 3 is multiplied 3 times. So it is 3 into 3 into 3. Minus 2 into minus 2 into minus 2 gives us minus 8. 3 into 3 into 3 gives us 27. So my answer is minus 8 over 27. Now we'll express the numbers in exponential form. Let's learn how to express them in exponential form. 125. To express the numbers in exponential form, we'll do the prime factorization. 125, we'll find out the prime factors. When I divide it by 5, I get 25. Again I'll divide it by 5, I'll get 5. Again I will divide by 5, I will get 1. So 125 is equal to 5 into 5 into 5. That means it is 5 raised to the power 3. Coming to the next one, just do remember that we have to do the prime factorization only. We just have to divide it using prime factors. 81 over 16. 81 over 16 will means that 81 is divided by 3, I'll get 27. Further it is divided by 3, I'll get 9. Further by 3, I'll get 3, and 3 divided by 3 gives me 1. So 3 is coming how many times? 4 times. So it is 3 into 3 into 3. Furthermore, I'll further prime factorize 16. 16 is divisible by 2. So dividing by 2, I'll get 8. Again dividing by 2, I'll get 4. Again dividing by 2, I'll get 1. So it is 2 into 2 into 2 into 2. 2 is coming 4 times. My answer is 3 raised to the power 4 as well as 2 raised to the power 4, which I can write it down as 3 over 2 whole raised to the power 4. Coming to the next example. Next example is 250. Now 250, let's quickly take out the prime factors. 250 divided by 2 gives me 125. Further, I'll divide it by 5. I'll get 25. Again dividing by 5, I'll get 5. And again dividing by 5, I'll get 1. So 250 is equal to 2 into 5 into 5 into 5. That means 2 is coming 1 time and 5 is repeated 3 times. So 5 will become 5 raised to the power 3. This was exponents and powers, but where are they used? They are used in computer memories. MB, GB, TB are all exponential numbers. Population grows in exponential form. Bacteria multiplies in exponential form. Wherever the growth is massive, we use exponents. Now, exponents are repeated multiplication. 5 into 5 into 5 means 5 raised to the power 4. 5 is the base, 4 is the exponent. Remember that any number raised to the power 1 is same number. Any number raised to the power 0 is 1. So this was Avneet with Planet Spark. Keep learning, keep growing. Don't forget to subscribe. To book your free demo, check the link in the bio or simply type pspark.in in your browser today.